Hi, so in today's video, we'll be covering around 10 components that we will be using in our day-to-day electronic projects that we'll be making as a beginner in the electronics field. So I'll be sharing a few components with you. So we'll be covering resistors, diodes, LEDs, capacitors, MOSFETs, push buttons, potentiometer, 5-volt DC fan. We'll be covering the types of jumper wires that you will be using in your electronic projects, and finally the breadboard that you will be using in your electronic projects. So let's start with the resistor first. This is a resistor. Uh, the basic function of a resistor is that it limits the current flowing through it so that it does not end up damaging any other devices that are connected on the other side of the resistors. So at one end, the power supply would supply current through the resistor, and at the other end, there would be a device which would be connected to the resistor. There are various types of resistors you could find, and by types of resistors, I mean there are various resistors you can find of different resistance ranges, ohmic ranges. So this one over here is a 220 ohm resistor. You could identify resistors with the help of specific color bands which are uh, drawn on these resistors. There are 330 ohmic resistors, there are 1 kilo ohm, 4 kilo ohm, 10 kilo ohm resistors that you will be finding in the market. A common way of identifying them is that what I said before. There is a table of color bands which you have to study and calculate.
Over here we have diodes. The basic function of a diode is that it allows current to flow only in one direction. Unlike resistors, diodes have polarities. That means that on both ends you'll have opposite polarities, positive and negative. So unlike a resistor, a diode will have polarities on each end. That means that on one end there will be a negative polarity, and on the other end there will be a positive polarity. Now, in order to identify which polarity is which, you need to identify that on one end of the diode there will be a silver strip, kind of a painting drawn on one end, and you have to then understand that that strip would be representing the negative terminal of the diode, and the other side, which would be a plain black painted side, you need to understand that that would be a positive terminal of the diode. So accordingly, you will be adjusting your device connections with respect to this diode.
In the description of this video, I'll be providing you with a document that outlines in detail the extra information on each of these components along with the high-res image of these components in case throughout the video you couldn't see the physical features or the markings on the components. The images that would be listed on the document will be clearer to you. Also, the components that I have bought in this video that I will be showing have been bought from a website, robu.in. The link to that website will be given in the description below. But please note that this is only for the Indian country, the Indian subcontinent. If you're watching from any other nation, so please feel free to browse your local electronic suppliers. Also, in the coming videos, I will be sharing uh, a few projects that I would be making, their details, their workings, etc. Now we will be studying LEDs. Now, a very distinct feature of LEDs is that you can see that on one side you will be seeing there is a short leg. On the other side, there is a long leg. If you see carefully enough, you'll see a short leg and a long leg. Now, why is that? Because the short leg basically determines the negative terminal of the LED, and the long leg determines the positive terminal of the LED. Now, of course, the basic function of an LED is that it glows when current passes through it. Now, I have a red LED in my hand, which is of 2 volts. You will find various LEDs in the market which would have different colors. So, blue, white, and green colored LEDs would be of 3 to 3.3 volt, voltage LEDs. Right in front of you, you have a electrolytic capacitor. Now, its physical feature, as you can see, is that one leg of it is short and the other leg is long. This feature we had studied in our previous component, which was the LED. And like the LED, it shares the same terminal characteristics observed in each leg. The shorter leg represents the negative terminal or the negative polarity, and the longer leg represents the positive terminal or the positive polarity of the electrolytic capacitor. Now, the basic function of an electrolytic capacitor is that it stores charge used for filtering and smoothing. Now, the markings which you would observe on these electrolytic capacitors are basically their capacitance and voltage ratings, which you can observe written on these capacitors. So these are the markings. If you observe carefully, you can see that this specific capacitor is around 100 microfarad capacitance and 25 voltage rating. In front of us, we have a MOSFET. The basic function of a MOSFET is that it works as a high efficiency electronic switch or an amplifier. Now, in order to assess the terminals of each these three terminals and to label them, we have to understand the physical features of the MOSFET. Now, what do I mean by physical features of the MOSFET is that if you rotate this MOSFET, you will understand that on one end of the MOSFET, it is a completely plane-faced MOSFET on one end, and on the other hand, you have a sort of a hemisphere. So on one end, you have a completely plane side. Now, in order to label the rest of the three terminals, you have to first align the MOSFET in such a way that it is facing you. That is, in this case, it is facing the camera. Now, on your side, the leftmost side terminal will be your source. The middle terminal will be your gate, and the terminal on the right will be your drain. So accordingly, you will be attaching your MOSFET on the breadboard, and accordingly you will attach the wires to the respective devices. So right now, in front of you, you have a push button. Now, as you can see, this push button is of 2 pins. Unlike in our previous components that we have studied, this push button does not have any shorter or longer legs. It is of proportionate length. This is because the push button does not have any polarities. That needs to be differentiated by its physical features. You can attach it to both these terminals to GND and voltage in any way you deem fit. The basic function of this push button component is that when you press the button on top of it, it is pressable. When you press the button, the circuit is closed. That is, current flows through the push button. And when it is open, right now it is open, so current is not flowing. That is, the circuit is open. So right in front of you, we have a potentiometer. Now the first feature that you can see is 10K. Now, this marking represents the resistance value of this potentiometer, which is 10 kilo ohms. Now there are various resistance values of this potentiometer that are available in the market. 1 kilo ohm, 10 kilo ohm, even 100 kilo ohm is available on the market. Now, a distinct feature of this potentiometer are the three terminals that you can see. So the opposite terminals if we measure the resistances across these opposite terminals, they form fixed resistances. But if we see the middle terminal, if we measure the resistance in the middle terminal, it will be a variable resistance. This potentiometer function is basically the function of this potentiometer is that it is a variable resistor which is used for adjusting voltage. Voltage as in, now we use adjusting voltage in cases such as if we have to adjust volume or sensitivity, etc. So right in front of you, we have a 5-volt DC fan. If you look at the specs of this DC fan, you can see that it is a DC fan 5 volt and 0.12 ampere device. As you can see, one of the physical features of this DC fan is that it has a wire attached to it, or rather 2 wires that are attached simultaneously together. That is, there is a red wire, and there is a black wire. The black wire will be connected to the GND, that is the ground, and the red wire will be connected to the plus 5 volt voltage source. At the end of the wire, you can see that there are 2 sockets which are given to you. So in these sockets, you are supposed to connect wires. You're supposed to connect the wires, and those wires will be respectively attached to the GND and the plus 5 voltage sources. End of this video, don't worry, I will be showing you how to connect each of these components to the breadboard. How do these connections look on the breadboard? So right in front of you, we have jumper wires, which are the most basic components of electronic projects. Now these jumper wires are categorized according to the pins that they have on opposing ends. So these are the 2 ends of these wires, as you can see, have pins on them. This is one end of this wire, this particular type of wire, and this is the other end of the wire. Now these types of wires are called male-to-male jumper wires. Male-to-male jumper wires. This wire, on one end you can see the pins, but on the other end you can see that there are no pins. Why are there no pins? Because these holes are used so that they can be attached, so that wires of other pins of other wires can be attached to these holes, like this. So these wires are called male to female jumper wires. On one end we have the pins, on the other hand we have the holes to which pins are attached from other wires. Now the third type of jumper wires are those on both sides you have holes. So unlike in this one where you have a pin on one end, on both ends you have holes. So on this end you'll have holes, and on the other end also you'll have holes. So those are called female to female jumper wires. So right in front of you, you can see that I have connected all electronic components to the breadboard. Now the question arises, where do I get my power supply from? If you are in a laboratory, you will get your power supply from any college apparatus that they would be providing you with. But if you are at your house, so a very basic thing that you could do is that you can buy these Arduino Uno devices. So these are basically smart devices. I won't delve much into the details. I will explain these devices in the next upcoming videos. But for now, I will explain the power supply issue. So this breadboard won't power itself. I will derive power supply from the Arduino Uno. This Arduino Uno will have a jumper wire, or simply a cable, not a jumper wire, a cable which will be attached to the laptop. The laptop will provide power to the Arduino, and you can see that there are pins that I've attached to the Arduino, from the Arduino to the breadboard. So the green wire that you can see is connected to VIN, and the blue wire that you can see is connected to GND. So the green wire is connected to the positive terminal of the breadboard, and the blue terminal, which is the GND, is connected to the negative terminal of the breadboard. The negative terminal of the breadboard can also be considered as the GND of the breadboard. It is also worth noting that on one end of the cable wire will be connected to the Arduino, and the other wire would look something like this. On the other end of the wire would look something like this, which is common to all Windows laptops. This end will be connected to the laptop. The laptop will provide the power supply. So this brings us to the end of this video. I hope you found this video enjoyable. You learned quite a lot from this video. If you want more info on the components, as I said before, you can refer to the document given in the description. In the upcoming videos, I will be combining and using these components in different ways to create projects that you will find interesting. So take care, and I'll see you in the next video.